Hi students, welcome to DSR Maths. Today's our topic is greatest integer function, or it is also called as step function or floor function. This is the most important function. Listen carefully. So, what is the greatest integer function? See, you take any real number. That real number can be written as some integral part and fraction part also, right? For example, if you take 1.23, so this can be written as 1 plus 0.23. This is integral part, and this as fractional part, right? Now, if you take one more example, 2.63. Here also, this can be written as 2 plus 0.63. Integral part, and this as fractional part. Now, I am asking for which real number we get integral part 3. For which real number we get integral part 3? So obviously we know that 3, because 3.0 in this one integral part is 3. Next 3.0001, this is also in this one integral part 3 is there. 3.2 in this also integral part 3 is there, etc. 3.99 like this you can take. In all these real numbers, integral part is what? 3 only, right? Now take one more example. So for which real number we get integral part 4, suppose. So here also 4, because in this integral part is 4 only. Suppose 4.1, 4.2, etc. 4.9. In all these real numbers, integral part is what? 4. So observe these two examples carefully. So these real numbers in the form of, see here, 4, close interval 4 to open interval 5. From this interval, any real number you take, in that integral part is what? 4 only or not. Next, come to this one, closed interval 3 to 4. In this also, you take any real number, in that integral part is what? 3. So if you generalize this one, so you can write it as closed interval n comma n plus 1, where n belongs to integer. So from this one you take any real number. For that one, integral part, in that integral part is what? 4 only, right? Means integral part of any real number denoted by or represented by like this, right? Now here, this integral part of this one is always less than or equal to x. Observe carefully. Integral part of any real number always less than or equal to that real number. Since integral part, now only you taken one example. So for which real number integral part is 4? So it starts from what? 4, 4.1, etc. 4.9. So here, if you take greatest integer function of 4 is less than or equal to 4, obviously not less than equal to 4 only. Next, if you take here, for greatest integer of means here integral part is 4, 4 less than or equal to 4.1. Next, if you take 4.2, so 4.2 integral part is 4, 4 less than or equal to 4.2, like this. Means this integral part of this one is always less than or equal to x, right? Means greatest integer function of 4 in this one, obviously it is what? 4 only. Next, here in this integral part of this one is 4 only. 4 integral part of in this 4.2 also 4 only, etc. Means why we are saying this is greatest integer function. Suppose if you take all these, suppose you take 4.1, here this has 4 and this has 5, and 6, here 3, here 2, 1, 0, etc. Now if you take here 5, here 6, 7, 8, 4.1 if you take here, this is the real number. So less than this real number, observe carefully, less than this real number, observe all the integers left side of this real number. Observe left side of this real number, all the integers. Among all the integers, which one is the greatest one? 4. So that's why greatest integer function of the real number 4.4 is what? 4. That's it. Suppose the greatest integer function of 5.2 is what? 5 only. Because in this one integral part, nothing but this is in this real number. What is the integral part? This is the symbol equal to what? 5. That's it. Now if you take here 5.2. So if you take here 5.2, left side of this real number, all the integers you observe. Among all the integers, which one is the greatest one? 5 is the greatest one. So that's why integral part of 5.2 is what? 5 only. Suppose you take 10.6. Integral part of 10.6 is what? 10. So here 9 is there, here 10 is there. So here 11. So 10.6 if you take here, left side of this real number, observe all the integers. Among all the integers, which one is the greatest one? 10. So that's why greatest integer of 10.6 is what? 10. Suppose if you take minus 5.6, negative value, one negative value take. So this real number also you take on real number line. So what is the actual meaning of greatest integer function I am discussing? After that definition I will give. See here 0 and minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7 and minus 8 lines. So minus 5.6. Minus 5.6 lies in what? Minus 6 and minus 5. Here anywhere minus 5.6. Here also same concept you follow. This is a real number. Left side of this real number, observe all the integers. Among all the integers, which one is the greatest one? Minus 6 is the greatest one. So that's why greatest integer function of minus 5.6 equal to what we will get? Minus 6. Don't take minus 5. This is wrong. Right. Next, if you take minus 2.5. What is the greatest integer function of minus 2.5? Minus 3. Same concept. If you follow here minus 2.5. Observe left side of this real number, all the integers. Among all the integers, which one is the greatest one? Minus 3. So that's why what you are getting? Minus 3. Right? This is the actual meaning of greatest. Why we are saying this is the greatest integer function? Means left side of this real number, so observe all the what? Integers. Among all the integers, you take the what? Integers. That is nothing but greatest integer function of minus 2.5. This is the symbol, nothing but in this one integral part. Right. Means this one is greatest integer which is less than or equal to what? X. Greatest integer less than or equal to x. And now come to definition of this one. From all these, if you conclude, you will get one like this definition. Let one real number, let x belongs to real number. Means one value I am taking x, which is belongs to real number, and n belongs to integer. So one value n I am taking from where? Integer. Such that n is less than or equal to x less than n plus 1. Now only you observe. If you take in this interval any real number, the integral part of that one is definitely what you will get n. So therefore, then greatest integer function of x is what? n. Listen carefully. Let x belongs to real number, n belongs to integer, such that if any real number satisfies this condition, n less than or equal to x less than n plus 1, then greatest integer function of that real number definitely equal to what? N only. By the two examples we taken that, right? Now, see here, suppose if you take 0 less than or equal to x less than 1, is it satisfying this condition? Here to here, what is the difference is there? One difference is there. Here 0 is there means here 0 plus 1, right? Now, what is the greatest integer function of this one? 0 only. Because 0 less than or equal to x less than 1 means in this one how many real numbers are there? 0. Suppose some real numbers if you take 0, 0.1, 0.2 etc. 0.9. Now in this one, in all these real numbers, integral part is what? 0 only. That only we are taking. Suppose 1 less than or equal to x less than 2. So here also integral part in all these real numbers, integral part is what? 1. Means if whenever x is lies between 0 to 1 and including 0, greatest integer function of that x is 0. If any value 1, 2, between 1 and 2, including 1, then greatest integer function of that x equal to what? 1 you will get. Take one more example. Suppose 10 less than or equal to x less than 11. Then greatest integer function of or step of that x equal to what you will get? 10 only you will get, right? Now minus 2 less than or equal to x less than, here what you will get? Here minus 2 is there means minus 2 plus 1 here you will get. So minus 2 plus 1 if you take, here what you will get? Minus 1. Now it is in between minus 2 to minus 1 means the greatest integer function of this one is what? Minus 2 only, right? Next suppose 0 less minus 1 less than or equal to x less than 0 means x value is between minus 1 to 0 including 1. So in this one what is the integral part? Definitely it is equal to what? Minus 1 only. Okay, now means the value x belongs to 0 to 1 including 0, step of x is 0, 1 to 2 including 1, 1, and 10 to 11 including 10, 10, and minus 2 to minus 1 including minus 2, 2 getting. Means in all these examples, see here, x equal to 1, integer 1, x equal to 10, integer 10, x equal to minus 2, integer, means greatest integer function of or step of any integer is always what you will get? Integer only. So this is important condition. Greatest integer function of any integer is what? Integer only, because obviously that is integer only, right? Now some more examples I will give. After that I will draw the graph of, because you should know the clarity, you should get the clarity about this one. Then if you draw the graph, then easily you can identify. So what is the domain of that function and the range of that function, and how to draw the graph of that greatest integer function also. Now see, step of this is nothing but in this one what is the integral part, that's it. Now 0.1 equal to what? 0, because it is in between 0 to 1. If 0 to 1, so integral part of that one is what? 0 only. Next integral part of 0.6 equal to what? 0 only. Next greatest integer or step of 1.7 equal to what? 1, because it is in between 1 and 2. So 1 and 2 means greatest integer function of that one is 1 only, because it is 1 to 2 means integral part is definitely 1 only you will get. Next here 3.6 equal to what? 3. Now minus 2.7, minus 2.7, minus 2.7 means it is in between here minus 2, here minus 3, here minus 4, means between these two, between these two, means between these two means anywhere. Left side of this real number, which one is the greatest integer? Minus 3 only. So that's why minus 3. Like this also you can, because many methods are there to identify the greatest integer function. So previously introduction is one method, one method, and this definition is one more method, like that. Means nothing but suppose here 0 is there, here 1 is there, 0 to 1. So integral part of 0 is 0 only. Integral part of 0 is 0 only. Integral part of 0.1 0 only. 0.2 0 only. 0.5 0 only. 0.9 0 only, like that. Next, integral part of minus 11.0. Suppose minus 11.0. What do we get? Not minus 12. Careful, observe this one. Because this is the integer, that is equal to what we will get? Minus 11 only. Integral part of minus 1.0. Minus 1.0 nothing but minus 1 only. That is equal to minus 1. But minus 1.1. Minus 1.1 means it is in between minus 2 to minus 1. So that's why what will get? Minus 2 will get. So careful about this one, right? Now draw the graph of greatest integer function. This is graph is most important. Zero, 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4. And here 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. Like this. Now, step of 0 or greatest integer of 0 is what? 0 only. 0.1, 0 only. 0.5, 0 only. 0.9, 0 only. Means including 0 to 0.9. Greatest integer function of any real number is what? 0 only. Between 0 to 1 and including 0. Right. Next, but greatest integer function of 1 is what? 1. So that's why here you won't get the point. Here you will get. Because greatest integer of 1 is 1. So that's why here. Now 1.1, 1 only. 1.2, 1 only. 1.5, 1 only. 1.9, 1. Means up to here 1 only you will get. Listen carefully. But at x equal to 2, what will get? Greatest integer function of 2 is what? 2 only. So that's why here point you will get, here you won't get. That's why open circle, here closed circle. Now, so 2.1, 2.2, 2. Up to 2.9, 2 only you will get. But 3, if you take 3, that is what? 3 you will get. 3.1, 3.2 up to what? 3.9. So 3 only you will get, like this. So here also, if any value including minus 1 to 0, so what you will get? Minus 1 only you will get. And minus 2 to minus 1, minus 2 only you will get. Minus 3 to minus 2, minus 3 only you will get. Right? Once again, listen. So greatest integer function are step of 0, 0, 0.1, 0, 0.5, 0, 0.9, 0. But 1, 1 you will get. 1.1, 1.2, etc. 1.9, 1 only. But 2, 2 you will get. Like that. Okay, no? So that's why here some steps are there. So that's why it is called what? Step function. Otherwise, if you consider it as a first floor, second floor, third floor, like that, that's why it is called as a what? Floor value function or floor function. So here, what is the domain and the range of this graph? Domain and range of the function y equal to f of x equal to this one, greatest integer function, right? So where this one is what? A greatest integer function less than or equal to x. Greatest integer function less than or equal to x, right? And now what is the domain? Domain equal to real number, because for every on x-axis, for every value we are getting what? Y value. So that's why all the real numbers exist for the domain, because for the definition you taken x belongs to R, let x belongs to R, real number, x nothing but domain. Input is domain. According to that input, what the output you will get? That one is what? Range. That's it. Now what about the range? Once you observe, what is the range? Means in this any real number you substitute, output what you are getting, integer only getting or not? Here n belongs to integer and step x equal to what you taken? N you taken. But n is what? Integer only or not? So that's why, see here, where dots are there? Minus 3, minus 2, minus 1, and here means all the integers only. Means nothing but in place of x, whatever the input from the real number if you substitute, Output what will get? Integer only we are getting. So that's why range is what? Integer. So domain of this function, greatest integer function is real number, and range of the greatest integer function is what? Integers. This is real number and integers, right? This is about the what? Domain and the range of the greatest integer function, right? Next, see the properties of greatest integer function. So in that first property, all these properties are most important. Listen carefully. So greatest integer of or step of step x equal to step x only. Since you take one x value x equal to 1.2. So here 1.2 step of 1.2 1. Again it is equal to 1 only. So here also 1.2 equal to 1. LHS equal to RHS. Next, second one. This is important one. Step of x plus n equal to step x plus n, where n belongs to integer. Among all these, this is one of the important one. Since you take here also x equal to 3.5 and n is any integer that is equal to 3, right? Now here 3.5 plus 3 equal to 6.5. Step of 6.5 in this integral part is 6. Now here also here 3 step of RHS, if you observe, this has 3.5 plus 3, that is equal to greatest integer function of, means greatest integer of 3.5 is 3 plus 3, that is equal to 6. Satisfied or not? So that's why step of x plus n equal to x, step x plus n, but here n should be integer, right? Next, third one, step of x plus step of minus x equal to, listen, equal to, it is 0 if x belongs to integer, minus 1 if x does not belongs to integer. This is also one of the important property. So take x value, which is x equal to 4.2, which is does not belongs to integer. If it is does not belongs to integer, step x plus step of minus x equal to what should get? Minus 1 you should get. Alright, right. Suppose if you take x plus step of minus x, replace here 4.2 plus this as minus 4.2, that is equal to, it is 4 and here minus 5, that is equal to minus 1. Satisfied or not? Suppose if you take x equal to 4, which is belongs to integer. Now here this has 4 plus step of minus 4, both are integers only. 4 minus 4 equal to what? 0 you will get. Like this you will get. Okay. Next, fourth one, x minus 1 less than step x less than or equal to x. Take any x value, any real number, definitely it is satisfies this condition. And fifth one, step x from this one less than or equal to x, this is definitely less than step x plus 1, right? Next, sixth one is step of x plus step of y less than or equal to step of x plus y. It can also be written as less than or equal to step x plus step y plus 1. You take any x values and verify, definitely it satisfies. Next one is seventh one. Generally, so here only two terms you taken. If you generalize this one, you can take like this: step x1, x2 plus etc. plus step of xn less than or equal to step of x1 plus x2 plus etc. plus what? Xn, like this you can write. And now here, when they are equal, step x plus step y equal to step of x plus y, if either x or y or both x and y are integers. X and y are integers. You take any x value, means if x is integer, this satisfies. Y integer, but both integers satisfies. Right. Next, ninth one. Step of n plus 1 by 2 plus step of n plus 2 by 4 plus step of n plus 4 by 8 plus step of n plus 8 by 16 plus etc. equal to n, where n belongs to natural number. This is a important condition. So you take any natural number, n equal to 3 I will take, which is belongs to natural number. Satisfied or not, once you see. So this has 4 plus 1 by 2. N equal to 3 you take, 3 plus 1 by 2 plus 3 plus 2 by 4 plus 3 plus 4 by 8 plus like this 3 plus 8 by 16 plus etc. like this. And now that is equal to 4 plus 1 by 2, 2. Step of 2, 2 only, right? Now once you see here, 3 plus 4, 5 by 4. Step of 1 point. 1 point means 1 only you get, right? Next, 3 plus 4, 7. 7 by 8, 0 point means here what you will get? 0. And 11 by 16, remaining all these are 0 only. So what is the answer? 3. So n equal to 3 equal to what? N. Like this, right? Now next, 10th one. This is also important one. So this is x by n plus step of x plus 1 by n plus step of x plus 2 by n plus etc. plus step of x plus n minus 1 by n. So it last term is what? X plus n minus 1 divided by n equal to step x you will get, where here also n belongs to natural numbers. Take any x value, x equal to 3.5 I will take, and n equal to 4 you take. Substitute satisfied or not? Step of x 3.5 by 4 plus 3.5 plus 1 by 4 plus 3.2 by 4 up to where we have to write n minus 1. N is 4, n minus 1 is 3 plus 3.5 plus 3 by 4 up to here only, no? Once you observe. Next, that is equal to 3.5 by 4, it has what? 0. And here 4.5 by 4 means 1 point. Step of 1 point, it is 1. And here 5.5 divided by 4 means 1 point something. Step of 1 point means 1 only, plus and here 6.5 divided by 4, so 1 point only. So 1 point means 1 only. So that is equal to what? 3. So answer is what? 3. Now what is the x value? What you taken? 3.5. What is the step of 3.5? Step of x equal to, that is equal to 3. Satisfied or not? So step of x by n, x plus 1 by n, x plus 2 by n, etc. x plus n minus 1 by n equal to, definitely what you will get? Step x you will get, where n belongs to natural numbers. Next. Next one. This one. Step x plus x plus 1 by n plus x plus 2 by n plus etc. Here I will write step x plus x plus 1 by n, x plus 2 by n plus etc. plus x plus n minus 1 by n equal to step of nx, n belongs to integer. So this is also important one. So here also I will take same example. You take x equal to 3.5 and n equal to 4. Verify. Substitute here step of 3.5 plus 3.5 plus 1 by 4 plus 3.5 plus 2 by 4. Up to where we have to write here also n minus 1. Last term is n minus 1. And one more term we have to write 3.5 plus what? 3 by 4. Right? So n is 4 means n minus 1 is 3. Now further simplify this one. Step of 3.5 is 3. And 3.5, this is what? 0.25 means 3.75. 3.75 step in that greatest integer is 3 only, plus, so here 1 by 2 means 0.5 plus 3.5, 4. So here 4 you will get. Next 3.5 plus 0.75 means 4 point. Step of 4.4 only. So 3, 6, 10, 14. Right. Now here our condition is what? N into x. That is equal to n. N is 4. And x what you taken? 3.5. Simplify. That is equal to 14 only getting or not? Same. So step x plus 1 by n plus x plus 2 by n etc. X plus n minus 1 by n equal to what? Step of n into x. Right? Now this one. For this one, I will take one more example. Generally, how to solve this type of problem whenever they given this type of problems. Second example on 11th one, you take. Suppose they given 3 by 4 plus 3 by 4 plus 1 by 100 plus 3 by 4 plus 2 by 100 plus etc. plus 3 by 4 plus 99 by 100 like this equal to what they ask. Once you see step x, is it in the form of step x plus x plus 1 by n, x plus 2 by n plus etc. plus x plus n minus 1 by n. Satisfied or not that condition? So actually from this one, what is the answer? N into x. Here n is what? 100. N equal to 100 and x equal to 3 by 4. Now step of n into x, that is equal to 100 into 3 by 4. So here this is 25, that is equal to 75. So by this condition directly you can take the answer 75. Right? But generally if you simplify, how to get the answer? Once you see. So this is nothing but, I will write like this. 3 by 4 plus 3 by 4 plus 1 by 100 plus etc. plus 3 by 4 plus 1, 24 by 100 I will take, plus 3 by 4 plus 25 by 100 plus etc. plus 3 by 4 plus 99 by 100. Observe carefully. Now here 3 by 4 0.75, 3 by 4 0.75 plus 1 by 100 is there. So up to here to here you observe 0 point, all these are 0 point something only or not. So greatest step of 0 point something is what? Here 0 plus etc. plus 0. How many times? So 25 times you will get. Because it starts from what? 0, here 1, 24. Listen carefully. Here 0, here what? 3 by 4 plus 0. Here 1 by 100. So 1 to 24, this is extra. 25 zeros. So all these are zeros only. Now here, from here onwards, once you observe, 3 by 4, 0.75 and 1 by 4. 1, no? So this step of this one is 1. After that also 1 point something. Up to here what? 1 point something only. So greatest integer of 1 point something is 1 only. So year to year, so how many times here? 25 to 99 means totally 75 what terms are there are so 1 plus 1 plus etc plus 1. How many times? 75 times. So that's why answer is what? 75. Like this we have to do the problems. Means by using these properties, many problems we are going to do. Okay, no? So most important properties I given. So listen carefully. So all these are once again you have to practice. Then we will go to what problems. How to apply this problem? Properties on problems. Okay, no? Right. 12th property. If step of x greater than or equal to n, then what about the x? Means x is greater than or equal to n or greater than or equal to n plus 1, less than or equal to, like that we have to identify. For that I will take one example. Suppose greatest integer function is greater than or equal to 2. Means step x equal to greater than or equal to 2 means what are the possible values? 2, 3, 4, 5, etc. are not. Now if step x equal to 2, whenever step x equal to 2 means for which real numbers greatest integer function is 2? 2 less than or equal to x less than 3. N less than or equal to x less than n plus 1 condition. Right? Next, if step x equal to 3, suppose how to write it as 3 less than or equal to x less than 4. Suppose if step x equal to 4, if you take 4 less than or equal to x less than 5, etc. Observe all these. From these three conditions are etc. What we can observe? X is greater than or equal to 2 or not. So 2 less than or equal to x less than, 3 less than or equal to less than, means definitely x greater than or equal to 2. Means x is greater than or equal to n. This is the important condition. So in this 12th property, this is first one. If step x greater than or equal to n, then x is greater than or equal to n. Right? Next. Second one in 12th property only. If step x strictly greater than n, then what about the x? So here also same example I will take. Step x greater than 2. Step x is greater than 2 means what are the possible values of step x equal to 3, 4, 5, etc. Because this is integer. Now if step x equal to 3, 3 less than or equal to x less than 4, right? If step x equal to 4, 4 less than or equal to x less than 5. If step x equal to 5, here 5 less than or equal to x less than 6. Suppose step x equal to 3, 3 less than or equal to x less than 4. Step x equal to 4, 4 less than or equal to x, like that we will get, etc. Means if you observe all these, we can conclude x is greater than or equal to 3 or not. Means x is greater than or equal to 2 plus 1, because if you take here 2 means step x greater than or equal to 3 means whenever step x greater than n, and what about the x value? X is greater than or equal to n plus 1. So previous one also we taken what? Step x, first one step x greater than or equal to n means x is greater than or equal to n. Their example what you taken? Step x greater than or equal to 2 means 2, 3, 4, 5, etc. Means step x greater than or equal to 2 means first one what you got? X greater than or equal to 2 only or not. When you will get step x is greater than or equal to 2, it starts from here only or not. So all these values satisfies. Here also whenever step x is greater than 2, step x is greater than 2 means definitely the value should start from what? Here only or not. Because from here if you take in that real numbers, greatest integer function is 3 only you will get. Right? Because step x is greater than 2. Like that also you can identify. From here you will get or not. step x is greater than 2 means integer from where it starts 3, right? So that's why close interval 3 to etc. Next, x greater than or equal to 3 means whenever step x greater than n, then x greater than or equal to n plus 1. Next, see the third one. Third one is if step x less than or equal to n, then what about the x? Here also I will take step x less than or equal to 2. Means what are the possible values of step x here less than or equal to 2 means? So etc. -2, -1, 0, 1, 2 also. Suppose if step x equal to 2, x value 2 less than or equal to x less than, so 2 plus 1, 3, right? Next, if step x equal to 1, 1 less than or equal to x less than 2. If step x equal to 0, so here 0 less than or equal to x less than 1. Now, etc. From all these conditions, what we can observe? X is what? Greater than or equal to 2 and less than 3 also. Means x is less than 3. Means x is less than 2 plus 1. Whenever step x is less than or equal to n, x is less than n plus 1. So this is also important one, right? Like this we can identify. Step x is less than or equal to n. What about the x? X is less than n plus 1. Next, fourth one. That is x is less than n. If step x is less than n, then what about the x? Here also step x less than 2 you take. Step x is less than 2 if you take. What are the possible values of step x here? Etc. -2, -1, 0 and 1 only, right? Because this is integer less than 2, so up to 1. Suppose if take 1, if step x equal to 1, so 1 less than or equal to x less than 2. Next, if step x equal to 0, 0 less than or equal to x less than 1. If step x equal to -1, -1 less than or equal to x less than 0, etc. Observe all these conditions. What we can conclude from all these conditions? Tell me. X is less than 2 only or not? Up to 1.9. Up to 1.9 step x value is less than. So next less than 2 means here step x is less than 2 means x less than 2 you got. Means what we can conclude here? X is less than n. So whenever step x is less than n, x also less than n. So these 4 conditions are most important to do this type of problems. So how to apply these conditions on problems? You take 1 or 2 examples. So this is the first one. Suppose if f of x equal to the given step x square minus 5 into step x minus 6. Otherwise, solve this one. Solve this equation. Step x square minus 5x minus 6 equal to 0 is there. Right. Now, if you take here plus, so take the factors. Step x minus 2 into step x minus 3 equal to 0. Can you write? One problem I taken step x square minus 5x plus 6 equal to 0. Take the factors. Step x minus 2, step x minus 3 equal to 0. Now, if greatest integer function equal to 2 or greatest integer function equal to 3. If step x equal to 2 means definitely 2 less than or equal to x less than 3 or 3 less than or equal to x less than 4. Can you write? Now, so again from these two, how to write 2 less than or equal to x less than 4. So this is our final answer. Means therefore x belongs to closed interval 2 to 4. right? So these values, x belongs to closed interval 2 to 4. If you substitute in this one, this satisfies the equation. Those values belongs to this interval satisfies the given equation, right? Next, take one more example. Suppose if you take find the domain of the function, like this they will ask. So one root of step x square minus step x minus 6, like this I take it one problem. Root of x square step x square minus step x minus 6. Take the factors, it is in the form of what? A square minus a minus 6. A square minus 3a plus 2a minus 6. So a common, a minus 3 plus 2 common, a minus 3. So a plus 2 into a minus 3 equal to 0. In place of a, what is there? Step x is there. So under root value, we know that under root value always positive. So that's why this one whole square minus step x minus 6 greater than or equal to 0. If you take the factors step x plus 2 and step x minus 3 greater than or equal to 0. We know that whenever a plus 2, a minus 3 greater than or equal to 0, if you take a number line, what you will get? A less than or equal to minus 2 or a greater than or equal to 3 you will get. Means in place of a, what is there here? Step x less than or equal to minus 2 or step x greater than or equal to 3. Now here in previous all the conditions n belongs to integers. Now if you take, so if you remember that conditions, directly you can put the answer. Otherwise same procedure, what the procedure we followed for the taking the condition, here also same thing we have to follow. So that is, suppose step x less than or equal to minus 2 means what are the possible values of the step x, etc. minus 3, minus 2, right? Suppose if step x less equal to minus 2, what we can take the condition? Minus 2 less than or equal to x less than minus 1. Can you write minus 2 plus 1 less than minus 1? Next, if x less than step x less than or equal to step x equal to minus 3, how to write it as minus 3 less than or equal to x less than minus 2, etc. Right? In all these conditions, what we are observing? X less than minus 1. So here from this one x is less than minus 1 you got. Or from this one step x values 3, 4, 5, etc. If step x equal to 3, 3 less than or equal to x less than 4. If step x equal to 4, 4 less than or equal to x less than 5. If step x equal to 5, 5 less than or equal to less than 6. So from all these condition is what? X greater than or equal to 3. Means x less than or equal to less than 1 and greater than or equal to 3. So final answer is what? X less than minus 1 or x greater than or equal to 3. This is the domain of the given function. Or you can write x belongs to minus infinity to open interval minus 1 union close interval 3 to infinity. All the values which belongs to this interval satisfies this function, right? Now this is the domain of the given function. And take one more problem. Suppose they given like this. Same problem like this they given. Domain of 1 by root of step x square minus step x minus 6. Previous one is root of only. This is 1 by root is there. So here also same. Step x square minus step x minus 6 strictly greater than. Previous one greater than or equal to 0 because it is in numerator, but it is in denominator. Equal to not possible. So here also if you take the factors, what you will get? Step x plus 2 into step x minus 3 greater than 0. How to write it as step x less than minus 2 or step x greater than 3. Right? Less than minus 2 greater than 3. So less than minus 2. Step x less than minus 2 means what are the possible values? Etc. Minus 4, minus 3. Right? And here what are the possible values? 4, 5, 6, etc. Suppose here step x equal to minus 3. So x exists minus 3 less than or equal to x less than 4. Minus plus means here minus 2. Next step x equal to minus 4. Minus 4 less than or equal to x less than minus 3, etc. So what is the condition here? Less than minus 2. What is the condition? Less than minus 2. So here x is less than minus 2 you got. From this one, if step x equal to 4, 4 less than or equal to x less than 5. Right? If step x equal to 5, 5 less than or equal to less than 6. Now from this one, what you are observing? X greater than or equal to 4. X is greater than or equal to 4. Means what is the condition here? X less than minus 2 or x greater than or equal to 4. Means minus infinity to x belongs to minus infinity to minus 2 union close interval 4 to infinity. Once again listen, important problem. This is greater than 0. Take the factors. Less than minus 2 greater than. Less than minus 2 means what are the possible? Means step x is less than minus 2. Step x is nothing but integer. Integer less than minus 2 means minus 3, minus 4, minus 5, etc. Suppose step x equal to minus 3. We know that. So n less than or equal to x less than n plus 1 means step x definitely what? N only, no? By this one only we are taking. Suppose step x equal to minus 3. Minus 3 less than or equal to x less than means here to here what is the difference is there? If you add plus 1, this one getting. So plus 1 minus 2. So here from this one minus 2 getting. And here step x is greater than 3. Greater than 3, what are the integers? 4, 5, etc. Suppose step x equal to 4. 4 less than or equal to x less than 5. And 5 less than or equal to x less than 6. Means all the x greater than or equal to 4 values getting or not. So that's why this is the domain of the given function. So like this that 4 conditions. So we have to apply that 4 conditions on this type of problems. But in that 4 conditions we have to observe n is belongs to set of integers only. Okay, no? Right.